Hi, you guys. Happy Wednesday. I hope all of you are doing well and that online school is going okay for you. Remember that in addition to supporting you with your earth science learning during this time that we're apart, I'm still your teacher and I still love you and I'm still here to support you in life as well as science. So definitely reach out if there's anything that y'all need. Today, I'm going to be talking about using the periodic table and periodic trends to understand how atoms are behaving and figuring out, why the periodic table is the way it is. You have two assignments, I guess, to complete with this. The first is just to take notes like you always do. If it's in blue, write it down in your notebook or on a piece of paper. We know that the act of writing helps us build pathways in our brain and helps us retain information. The second thing is a digital student response sheet that I would like you to respond to as we're going through the notes. I think that this is going to help you process, just like we usually do in class with our think pair shares and our write pair shares. But this way we can have a little bit of processing even though we're not all together. Okay, so both of those things are important for you to turn in to keep ourselves accountable for our learning, even from far away. Okay, so periodic table, it's a lovely thing. It is full of information for us, including the element of surprise. Just kidding, that's not really on the periodic table, but that would be hilarious if it was. What we do have on the table is a lot of patterns. The periodic table was organized based on patterns. This dude, Mendeleev, and a couple other people also at the time were really just, trying to organize the 20-ish elements that we knew about at that time. And by looking at these patterns, they were able to create a table that really allows us to understand how atoms and elements behave, which for me seems pretty handy. I'm a chemist, so I acknowledge that I'm a little bit biased. Take a minute to think back to last quarter when we were talking about atoms and Bohr models. You might have to dig deep, but it should be there somewhere in your brain. Write down as much as you can on your student response sheet, or draw if you want to draw something. You can insert a drawing. But just try to communicate everything you can about atoms and Bohr models for 60 seconds. You can pause the video. I'm not going to sit here for 60 seconds and be silent. That would be really awkward for me. And it's, as you know, it's all about me. Okay. So now we want to think about how do we draw a Bohr model. So I've embedded this video for you. I want you to follow along and draw this Bohr model in your notes as this guy is drawing the Bohr model. Okay, so take a minute and draw this Bohr model along with our guest lecturer. like that video because that guy is just as much of a dork as I am. Anyway, there's the example for carbon. And all Bohr models follow the same few basic rules that he used to draw that carbon atom. The first ring only has 2 electrons. You can never put more than 2 electrons on the first ring. Every ring after that can have 8 electrons. It doesn't have to have 8, but it should have no more than 8. Protons and neutrons are always represented in the middle. This is representing the nucleus. Based on this description, I want you guys to go through, that's not what I want. I want you guys to go through and think about depicting the subatomic particles in the atom. The Bohr model is not accepted as literally accurate, but it's a really approachable way to talk about atoms and how they behave. So it's a really powerful model for us. On your student response sheet, you should double click on the image in your notes and label the protons, neutrons, electrons, and nucleus, and then answer the following questions. How many protons does this atom have? How many neutrons does this atom have? And how many electrons does this atom have? You should pause the video now to complete this. All right, so now we can talk about the answer. The red dots in the center of the atom that have the plus sign on them are our positive protons. The green circles with the white outline in the center that have no symbol on them are our neutrons. They have no symbol because they are neutral and they don't have a charge. The big green circles on the rings around the nucleus are our electrons. They have the negative symbol on them because they are negative. And the nucleus is the blue, purple, and yellow circle in the middle. Looking at this Bohr model, we can see that it has 3 protons, 4 neutrons, and 3 electrons. It would be really tricky for us to have to draw out a Bohr model every single time we want to talk about an atom. It wouldn't really be practical. And so because of that, chemists gave names to different elements, and they also created an atomic symbol as a shorthand way to be able to communicate about the different elements. So in your student response sheet, please answer the following questions. Looking at this little tile from the periodic table, what do you think the 3 could mean? And what do you think the 6.94 might mean? This tile matches the Bohr model that was on the previous page, so the one with 3 protons, 4 neutrons, and 3 electrons. And so that might help you a little bit. Please pause the video and answer the questions. Okay, so the top number is the atomic number. That number tells us the number of protons. So in our Bohr model, we drew 3 red protons with white crosses, and that tells us that there are 3 protons, which means it has to be lithium. The protons tell us which element the atom is. If an atom has 3 protons, its identity is always lithium. If it has more than 3 protons, it's not lithium. If it has less than 3 protons, it's not lithium. And so that atomic number becomes very important for us to know. The bottom number is the atom's atomic mass. You notice that for this and most of the elements on the periodic table, the atomic mass is not a whole number, it's a decimal. And this is because it represents the average of all possible mass numbers for an element. Most of the mass in an element is made up by the protons and the neutrons. And so if we simply add protons and neutrons together, we should always get a whole number. And that whole number is known as the mass number. So the sum of the protons and neutrons in the nucleus gives us the mass number. And elements can have different mass numbers depending on how many neutrons they have. So our equation that helps us determine the mass number is protons plus neutrons equals mass number. The number number of neutrons in an element can change. We said that the number of protons cannot change because it would change the identity of the element, but the neutrons could increase or decrease without causing any problems for the element. So lithium could have 3 or 4 neutrons and therefore can have a mass number of 6 or 7. The mass number is indicated by writing a superscript to the upper left of the atomic symbol, or by writing a dash followed by the mass number to the right. So here's an example for lithium. You could write lithium with a mass number of 7 as superscript 7 lithium, or you could do Li-7. If you wanted to talk about lithium with a mass number of 6, you could do 6 Li or Li-6. Now I want you guys to take a moment to go through and figure out how many protons and how many neutrons each element has. You should use your periodic table to find the number of protons and then subtract the mass number to get how many neutrons. So for example, for number 1, beryllium, we would find Be on the table. Be is number 4. That means it has 4 protons. And since its mass number is 9, 9 minus 4 means it has 5 neutrons. Please pause the video at this time to finish questions 2 through 5 on your student response sheet. Okay, let's double check our answers real quick. Sodium is number 11 on the periodic table. Its mass number is 23. 23 minus 11 protons tells us there are 12 neutrons in sodium. Number 3 has nitrogen 14. Nitrogen, N, is number 7 on the table, so it has 7 protons. The mass number of 14 minus 7 protons gives us 7 neutrons. Number 4 is also nitrogen, but it is nitrogen 15. Still 7 protons. 15 minus 7 gives us 8 neutrons. So this nitrogen has an extra neutron compared to nitrogen 14. Last, we have phosphorus. Phosphorus is number 15, so it has 15 protons. 31 minus 15 gives us 16 neutrons in phosphorus. The other particle that can change on an element is the electron. So look at these 2 carbon atoms below. These are both ions. Consider what is different about these 2 atoms and write a definition for an ion, a cation, and an anion. You should pause the video and write your responses on your student response sheet. Okay, so at this point, we're almost out of time for this video recording. And so you should move on to part 2 after you finish your response on your student response sheet.